Okay. So let me be very honest because I like to be. First, once again, I hope you had a wonderful holiday. I'm glad you're all back safely. It is one of my biggest fears for you not to be. You can think, oh, that's strange, Mr. H. You're my kiddos. A-Day kiddos, I'm sorry. I told you that there was going to be a video, and there was. My computer died the very last hour of the day, which is why there was no video. So I made that 6-minute video to help you review for the test. This is the longer video that's going to help you review for the test. So we're going to do the review. You guys just happen to be on video because truly my computer died on, what day was that? Tuesday of last week. And that really bothered me. It was like a nice 55-minute video and screwed it up. Okay. I have been going too fast. Not with the material that we are learning, but with the material that I've expected you to already know. Not only did you miss a couple months of school last year, but you also skipped all of 8th grade pre-algebra. So those are a couple things that we really need to start working on, is getting those gaps filled. So we're going to see more and more examples like things like this, and I'll explain why. So this question says, this given graph represents the set of ordered pairs that are solutions to a system of inequalities. And then it says select all the inequalities. I'm not worried about this. I'm only worried about this. Where are the solutions to this system of inequalities? What am I looking for when it talks about solutions to a system of inequalities? Brooke?
Where the lines intersect.
That would be a system of equations. What are we looking for the system of linear inequalities? Garrison?
Where it's shaded in.
Yeah, where it's shaded in. All of this shaded in area is solutions to whichever equations made that. So when it says select all the inequalities that represent the set, this means you need to know how to find the equations of this line, of this line, and of this line. So what I'd like you to do now, and it's going to be a little different than the directions on here, I want you to start by writing the equation for those lines. You should have 3 equations for the lines. Now, I don't expect you to know how to do 2 or 3. If you do, great. I've shown you during the prep module, and we've talked about it this much, not very much. Number 1, you should absolutely know how to make the equation. So put these in slope-intercept form. Go. And yes, folks, I'm going to have my phone out a lot because I don't have my watch on. I don't know why I didn't put a watch on this morning, but I'm going to use this as my timer because I've got this class pretty much timed to a T, which means I don't want to not get through all the test. And this is why I love this kind of question, because right now, some of you are like, cool, I have no idea what I'm doing. Even though it's a multiple choice, and yes, you could have guessed, you needed to select 3 different answers in this multiple choice. If you got any of them wrong, if you got 2 of the 3 right, you still missed the question. And that's going to happen on your end of course test. And even though this year has been absolutely crazy, and we still don't know what's going to happen when we come back, because again, we want to stay in person. We want to stay in person. Trust me, we want to stay in person. But they haven't canceled any of the end of the year tests. And the EOC for algebra, you need to graduate. So it's extremely important that we still know how to do these kinds of questions. So I want line number 1 in slope-intercept form. What 2 things do I need for line 1? Come on, I need somebody other than Brooke. Brooke's got this. What 2 things do we need to put it into slope-intercept form? What 2 variables? Let's start with that. Go ahead. We're still
You're going to need your rise over run.
Which is which variable? Do you remember?
M.
Good. My slope and?
And your y-intercept.
My y-intercept, very good, which is b. Okay. Which is easier to find, M or B? Faisal, which one do you think?
B.
B. What's it going to be?
5.
Yeah, my y-intercept, y-axis, we go up 1, 2, 3, 4, 5. Simply by looking at the line from left to right, it's going downhill. Addie, what does that mean for the slope if it's going downhill? It has to be? Say it again. It's going to be negative. So now we're down 1, 2, 3, 4, 5. Negative 5 over 1, 2, 3, 4, 5. Okay. Those of you who had me last year, and now those of you who have me this year, should know that if you put this as part of an answer, I'm going to want to vomit in my mouth and throw things at you. Why? Because it's not simplified. So we always have to simplify, which gives me negative 1 divided by 1, which really gives me negative 1. Computer people, you still with me? Yes, no? Hello, computer people? Anybody want to answer? Like, come off mute, say something?
I got it.
Okay, perfect. Thanks, Jack. So, now we're here. We're not done yet because we need to make the equation. So y equals mx plus b, y equals negative 1x plus 5. I wouldn't keep it as negative 1x because you're not going to see that. You're going to see y equals negative x plus 5. Now, let's break this down a little bit more. The given graph represents a set of ordered pairs that are solutions to a system of inequality. This is an equation, not an inequality. So now we need to look at this line. It's solid, which means that it does keep part of the equal sign. Which way did we shade? Did we shade above the line or below the line, Aaron? Above. So do you remember which one has to be above? Is it less than or greater than? Perfect. So the equation for that line, or the inequality, I'm sorry, for that line is y is greater than or equal to negative x plus 5. Still with me? Have I lost anybody's? Okay, that was a lot of work, right? Okay. Number 2. Does it pass through the y-axis? Does it? Yes. At what? At 5. Does it have any slope? Does it go up? Does it go down?
Down.
This is going down?
Oh, no, it doesn't.
It doesn't go anywhere. It's staying flat. Horizontal lines have no slope. We physically put y equals, and wherever it crosses the y-axis is the answer. So y equals 5. Except again, this is not an equation. It needs to be an inequality. Everybody still with me? So, Owen, am I shading above this line or below this line? So I'm shading this way?
No, below.
Below. Okay. Is it solid or dashed? Is my line solid? Solid. So we keep the equal part. If we're shading below, is that less than or greater than?
Less than.
Perfect. So there's my equation. And I said equation. There's my inequalities. We've got 2 of the inequalities. Have I lost anybody yet? Okay. Now we're to the tough one. This is vertical. Does it pass through the y-axis at all? There is no y-axis, therefore there is no y equals. Just like a horizontal, we put a variable equals. This time it's x equals because it's only intersecting the x-axis. Horizontal lines are y equals. Vertical lines are x equals. Still with me? So what do we think it's going to be? X equals what? What number? Brady, what do you think? Say, I'm sorry, couldn't hear you. 5. Is this my answer, though? No, because of the word inequalities. solid line, so I'm going to keep part of that equal sign. Am I shaded above or below? Well, wait a minute. There is no above or below. It's shaded to the right. What do we think? What sign are we going to put? Ella? Greater than. Again, I need to do a better job of making sure you know how to write equations from a graph. You will have a video today that will include the test review and how to go from a graph to writing the equations. Everybody with me? That will be part of a fair game quiz, which we'll talk about later. Okay, let's do one more. May I erase this, or are we good? So, that was a very low-scoring question of ours. Here's another one. Oh, I'm sorry, I said 4%. 6% of us got it. I'm sorry. And I think this is it. 24% of us got this one. Is this it? Yes, it is. Okay. You're able to see answers. Don't worry about them. You don't know what those mean yet. This is another thing that we hadn't taught yet when you took the test. So the fact that some of you guessed correctly and got 24% of this is amazing. A system of two linear equations is shown below. Henrietta claims that replacing the equation 2x plus 3y equals 6, so replacing this one with something else, would produce the same solutions. Select 3 that can be used to support Henrietta's claim. Now that we know how to solve systems, that's what I want you to start with. So right here, solve this system. Go and do that, please. I personally would solve it with elimination. That's me. So I want you to solve that system. How am I doing on time? Okay. Doing all right, I think. Computer people, you guys doing all right? Hello? Computer kiddo? Nice check. Okay, so I've got my bottom equation. I am using the multiplicative property of equality, which means that I have to multiply every single thing to make an equivalent equation. Questions there? Could you multiply by negative? Sure, but I don't like to add that extra thing in there. There's no reason to. am I going to add or subtract these equations to isolate my variable? Am I going to add or subtract and why? Add.
You're going to add this then.
Because they're what?
Opposite sides.
Yeah, they're opposite signs with the coefficient for the x. This is the additive inverse. 2 plus a negative 2 is 0. So that eliminates. 3 plus 8y is 11y. 6 plus 16 is 22. I divide by 11. Y equals 2. Have I lost anybody there? Okay. So now I'm going to substitute in. I'm going to choose my top one, 2x plus 3y equals 6. 2x plus 3 times 2 equals 6. 2x plus 6 equals 6. Subtract 6. 2x equals 0. Divide by 2. X equals 0. Okay? So my ordered pair that I get is 0, 2. Now, let's talk about systems real quick. So far, every system that we have solved for intersects at one point. That's what makes a system a system. But are there other choices for systems? Sure. If they're the same line, then there's infinitely many solutions. How would we get no solutions? If we had two lines, how would we get no solutions? What would the lines have to be? What do you think, Garrison?
Parallel.
Parallel. They would never intersect, which means the slope is the same, but your y-intercept is different. To have parallel lines, the slope is the same, but the y-intercepts are different. So I now know that these systems intersect and have an ordered pair of 0, 2. We want to see which of these can get replaced and still have an answer of 0, 2. So what do we do now? How do we check to see if these would work? What do you think, Heisel?
I got nothing.
Okay, that doesn't help me. What are we going to do with this ordered pair?
Oh, wait, substitute it.
Yeah, substitute it in. I knew you'd get there. So I'm literally going to substitute 0, 2 in to each equation. If x is 0, that's gone. 7 times 2 is 14. Does 14 equal 14? Yep. This question looks harder than it is. 2 times 0 is 0, so that's gone. Plus 8 times 2 is 16. Does 16 equal negative 16? No. 4 times 2 is 8. No, it's not. 4 times 2 is 8, but there's a 0. 4 times 0 is 0. Negative 5 times 2 is negative 10. Does negative 10 equal negative 10? Yep. Negative 0, that's gone. 15 times 2 is 30. 30 equals 30. Once you find the solution, you can substitute it in to see if it works for every other equation. Questions on how we do that? Kiddos, you guys good on the computer? I'm going to try to see if I can find you.
Yes.
Yep. Okay. So let's talk a little bit about what's happening before the end of the semester. First off, now is not the time to coast. We have, counting today's class, 1, 2, 3, 4, 5, 6, 7, 8 days. Counting today's class, we have 8 days worth of material. Okay, well, let's get rid of today because it's a review. So now we're down to 7. Well, let's get rid of the test because that's not teaching. Now we're down to 6. We have the fast bridge test, so let's get rid of that. Now we're down to days 5. When you go down to 12/17, so December 17th, it's the Thursday before that short week, you have what's called a fair game quiz. So you have a big test, you have a quiz. Nobody can drop the first quiz anymore. You're past that point. So now you either keep that, well, you're going to keep that, and you can drop this one, or you can use this quiz to raise your grade. So what do I mean by a fair game quiz? Anybody want to take a wild guess? Garrison?
Everything on the quiz is fair game.
Kind of. Not everything on the quiz. How about everything we've done this year? Everything we've done from lesson 1 from the prep modules until that quiz is fair game. Now, am I going to be unrealistic and be like, I showed them this one problem once on the prep module. It's going to be on the test. No. So remember when we did those graphs and we had to make the story for it and we did all that like the very beginning of the year? Have we done that since then? Do you think that's going to be on the quiz? No. Let's think about things that are going to be on the quiz. Man, does Mr. H really stress equations? Yeah. Does he stress knowing how to graph? Yeah. Do we do a lot of systems? Yes. Has he been stressing, hey, we need to know how to write equations from a graph? Yes. Those types of things will be on your quiz. Everybody with me? So that is December 17th. You have a test on Thursday, you have the fast bridge next Friday, and you have a quiz the following Thursday. So Thursday, Friday, Thursday. Everybody with me? Okay. You need a piece of paper. Those of you at home need a piece of paper. That's it. Computer people, how's my glare right now? Is the glare all right? Yes, no? Yeah, the glare's good? Okay. This is your test. This is your test. I am going to go exactly through the test. Miss Rachel, you trying to bump our grades? Yeah, a little bit. Yes, I am. I'm trying to give you a freebie. Hopefully you pay attention and do the work. So the first thing I'm going to do is we are going to have 3 quizzes. Quiz 1, quiz 2, quiz 3. You are going to make dot plots for each of these quizzes. I would suggest copying everything down that I do on the board. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So, take your time. You will not need a calculator at all for this test. You will not need a calculator at all for this test. You will need to make dot plots right now of this. So personally, how would I make the dot plot? Well, I'd have number 1, number 2, 10, 0, 1, 2, 3, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. Who just joined me? Did somebody get kicked off and then have to rejoin? Gotcha. 0, 10, 1, 2, 3, 4, 5, 6, 7. So you're making dot plots for these. Give you about another minute. Questions on how we make the dot plots? Okay. I'm truly going to read the questions. The key to this test is not the answer itself. The key to this test is being able to explain your answer. Even if you miss the answer and your justification is great, I might lean and give you more points. So the key to this is explaining. So here's the first question. On which quiz did the students tend to score the lowest? Explain. If it was me, and I'm just saying, if it was me who's sitting there, and I know that Mr. H is reading straight from the test, and I have a pencil in my hand, I might write down the questions. Which quiz did the students score the lowest? Explain.
Mr. H,
Yes.
For some reason it looks like your camera's off on my end.
On whose?
Yours, for some reason, it just has the letter N.
Everybody else that's on the computers, can you guys see me? Jordan, can you see me or no? Yes, you
You're
can.
frozen.
Huh?
You're frozen.
How about now?
There you go.
Okay.
There you go.
Okay. Let me know if it happens again. Sorry. So again, the justification, the reasoning, the explanation is the best. So, which one? Brady, which quiz do you think we scored the lowest on? Why?
Because all the schools you have to do, there's like none above 8, none above 9, they're all low.
Okay, but that doesn't tell me why it's the lowest. You just told me why they're not the highest. That's not the same question. Why is quiz 1 the lowest scores? Ella.
Because most of the scores are just in that vicinity.
In that vicinity, that you would lose points. Garrison.
Lowest score because if you were to find the mean, the median would be the lowest.
So if I was to find the mean and the median, it would be the lowest. Okay, now we're getting there. Let's go even easier. 6 scores are at 5 or lower. Does everybody agree with that? 1 score is at 5 or lower. 3 scores are at 5 or lower. This quiz 1 has the lowest scores because 6 of the 10 possible scores are at 5 or lower. That's all I would need to say. You're using the visual representation of what's up there. Could you find a mean and median? Sure. Could you justify using that? Absolutely. If you want to work some things out and use your calculator, more power to you. 60% of my scores are at 50% or lower, where none of the other one. This has a low score. This has 3 at 50, but 3 at 50 doesn't give me 60%. That's only 30% of them. Everybody with me? Have I lost anybody on number 1? Okay. Question 2. Without, and this is the question that I disagree on. The answer on the test that Engage New York gives me and my answer are very different. This is why explanations matter. Without performing any calculations, so no calculators, which quiz tended to have the most variability in the student's scores? Justify your choice. So which one has the most variability and explain why? So which has the most variability and why? There's really only one wrong answer, and there's 2 correct answers depending on your explanation. The explanation is what's going to give you the credit on the test. So you need to be able to write sentences and explain well. If I can't read your writing, which some of you I can't, yeah, you'll end up missing those. So, computer person, somebody from the computer world, which one do you think has the most variability? Hello, computer people. Somebody come off mute. Okay, I'll just call on you. Jordan, which one do you think has the most variability?
Number 3.
Okay, why do you think number 3 has the most variability?
Because it's even.
Okay, so that answer is wrong. I appreciate your willingness, Jordan. That's the only one that's not possible, okay? You'd have to give me a really heck of a great explanation. Jordan, do you know what variability is? Yes, no? Come off mute.
Not really.
Okay, there's good. Variability is how spread out things are. What's the variable distance away from things? This is relatively close. 80% of my numbers are between 5 and 7. How do I know that? Because 8 of my numbers are between 5 and 7. Can somebody give me another choice for variability? Which one? Go ahead, Owen. 2. Okay. I personally would agree with 2. Engage New York doesn't. So you better give me a great explanation. Go ahead.
Quiz 2 has the most variability because it's spread out more than the others, because the 3 is further away from all the others.
Okay. So to clean that up a little bit, I do agree with 2. He says it's the most spread out. I would say the range is the greatest in number 2 because between 9 and 3, there are 6 spaces. Now, is that a wide variability? Yes, it is. The problem is 80% of the scores are between 7 and 9. 3 is an outlier. So Engage New York is saying, hey, they're clumped up right here. That's not showing a great variability. They're saying quiz 1 has the most variability. Can somebody explain why? What do you think, Brooke?
Because there's only 2 quiz scores at most.
Okay.
Each one. I guess that's it.
Okay, so here's how I would explain this. Though they are distributed evenly, there is no clumping of scores. Notice how here I've got scores clumping here, I've got scores clumping here. If I try to do that, well, I can't clump the scores together because even though it's evenly distributed, it's spread out evenly as well. So there's nothing saying 80% of the scores are between these couple numbers. It's everybody has the same chance to get every single grade. That's why that's an option. As long as you are able to explain it, you'll get full credit. Questions? Okay, moving on. Here we go. This is a good one. If we were to calculate quiz 1's scores to calculate for a measure of variability, would we use interquartile range or standard deviation and why? So to find the variability of number 1, would we use interquartile range or standard deviation? And I'm not going to lie, I didn't think anybody would get this. Somebody in my B class on Monday, or on the last day, not only answered it, but answered it like she was reading things out of my head. So Sid, great job. You're the one that gave this great answer. Am I going to use standard deviation or interquartile range to measure the variability, and why? So IQR or standard deviation, and why? What's the best measure of variability? IQR for this problem or standard deviation? And it comes down to, what does the graph look like? Okay? Who thinks they've got an answer for me for number 1? Am I using IQR or standard deviation? Go ahead, Garrison.
You use standard deviation because it's not a box and whisker plot. And box and whisker plot used in interquartile range.
Okay, but I can make that into an interquartile range. That's not that hard. We can make it a start. Because you'd have to use a calculator in a way to find standard deviation, which also gives me box and whisker. So I do agree that it's standard deviation, but why? So now we need to talk about what's the difference between interquartile range and standard deviation. And Garrison already told us this. Garrison said interquartile range was with a box and whisker plot. What do we use to make a box and whisker? What mathematical terminology do we use to make a box and whisker? We use the median to find a box and whisker. So interquartile range is dealing with medians. What does standard deviation deal with? What do we need to know in order to find the distance from the average? That's what standard deviation is. Yeah, you need the mean. So interquartile range is dealing with median. Standard deviation is dealing with mean. Is my graph symmetrical? Is this a symmetrical data set? Yeah, it's exactly symmetrical. It's split on both sides. When graphs are symmetrical, which is better to find the center? The mean. So to find the variability, if it's symmetrical, we would use standard deviation. If it is non-symmetrical, if it is skewed, then we would find the IQR for variability. Everybody with me? And Sid, again, is the one who said, she said it better than I just did. It was impressive. I was like, oh, good for you for listening. Questions. Mean, standard deviation if it's symmetrical. Median, IQR if it is skewed. Okay. Ah ha ha ha. Love it. In quiz number 3, I want you to move one data point so that the standard deviation is larger. So move one data point in number 3 to change the standard deviation to make it larger and explain why it would be. So move one data point in quiz 3. Tell me where you moved it to and explain why it makes the standard deviation larger. Jack, which point did you move? Jack. Jack? Jack! Jack, can you hear me, Jack? Jack. Jack, are you frozen? Well, this is embarrassing, Jack. Kennedy, which point did you move? Kennedy, you're on mute. So you're talking and you're just talking. There you go. Hi, Kennedy.
I moved the 1 to the left.
There is no ones.
No, I can't see. The 6
Okay, this 6 to where?
to the 5.
That would be pretty much the only place that you couldn't move it.
Oh, okay.
So yes, I agree moving the 6. I'm going to move it to an extreme. So I'm going to move it down here to 0. Because remember, standard deviation is about the mean. Have I now changed the mean? Absolutely. Have I changed the distance from the mean? Well, yeah, because this is way down here. So even if the mean's here, that's farther away than it was. That's one option. Could I take this 5 and move it up to 10? Sure. Why? Because the mean changes, which means the standard deviation changes because the range got bigger. Yes, ma'am.
Why would you not move the 6 to the 10?
I could move the 6 to 10.
Why not?
No, I said I could.
Oh.
You could absolutely move it to the 10. It doesn't matter which point you move, as long as you move it enough that it's going to change the mean and the variability. The key is it has to be far enough away so that the standard deviation is now changing the distance away from the average. Okay? Questions on that one? Okay. Last one. Here we go. Actually, when I say last one, this is all one question. All of this has been one question. 0, 1, 2, 3. 5 students do a warm-up. It's a 3-point warm-up. I want the standard deviation to be the same. I'm going to phrase that. I want the standard deviation to be as small as possible, which means the standard deviation can be 0. Make a dot plot with 5 people so that the standard deviation is 0. That would be the smallest that it can possibly be. Where would those dots have to go for this to be the smallest possible standard deviation? 5 students, yes. Okay, somebody give me an answer. We should got this. This should be quick. What did you get, Heisel? Tell me what you put, because you're not wrong.
Okay, so I just put all of the points on 2.
Okay, so Heisel put all 5 points on 2. Absolutely. Because if they're all the same, the mean is the same, the distance away from the mean is 0, therefore my standard deviation is 0. Could I put them all at 0? Sure. What if I put them all at 1? Sure. What if I put them all at 3? Sure. But you also need to think about the inverse. How would I put these points so that the standard deviation is the biggest? Okay. You're going to have to draw another one. So we've got minivans. We've got sports cars. And we've got miles per hour. So we've got 30, 40, 50, 60, 70. So you will absolutely want to have these. So I take it Jack was embarrassed and left. That's sad. Sorry, Jack. Okay, we got to pick up the pace a little bit. Here we go. So, based on the block plots, which type of vehicle has more observations? And by observations, that means which one has more data? The minivans, or the sports cars, and why? Which has more observations, the minivans, the sports cars, and why? What do we think? Which one has more observations? This is an easy one. Garrison.
Minivan.
Huh?
Minivan.
Why?
Because you have more data in your 50% of data than you do sports cars.
Okay, how do you know?
Because it covers more space on the graph or the line.
Okay. Who agrees with Garrison that you said minivans or sports cars? You said minivans. Okay. Who agrees with Garrison that it's minivans? Uh-oh. Garrison, nobody does. Okay. Tell me about sports cars then, since if you don't agree with Garrison. Brooke.
I think it's sports cars because the line is farther to the right.
Oh, the line's bigger. Brooke, that's an awesome idea. Who agrees with Brooke? Okay, you're all wrong. None of you are right. Box and whiskers tell us what? The medians. Do we know how many numbers created this median of 50? Does it say anywhere on there? It could be 5 numbers. It could be 500 numbers. A box and whisker is not like a dot plot where we can count the number. It's not like a histogram where we can count the frequency. A box and whisker just says, hey, whatever the data is, 25% of your data is between 30 and 60. 25% of the data is between 30 and 40. It doesn't tell you how many observations were done of each. You cannot understand that from a box and whisker. So it's neither. We cannot tell. Everybody with me? Okay. Which vehicle is faster and why?
Minivan.
So which vehicle is faster and why? So you're going to need to explain your answers using numbers. And I would even say explain your answer using percentages. So which is faster and explain. And we need to do this in like a minute because your bell's going to ring. So I'm going to answer this one. You ready? Sports cars are faster because 75% of the cars observed were going 60 miles per hour or faster. How do I know it's 75%? Because in a box and whisker, 25% of my cars are between 30 and 60. 25 are between 60 and 70. 25 are between 70 and 75. And 25 are between 75 and 90, with an outlier at 120. In minivans, 75% of my cars are actually less than 60 miles per hour. Using the percentages from the box and whisker, sports cars are faster. Questions? You have a test on Thursday.